All right, today is the end of the 13th week. And however far we get today, we're finished with the course. All the new stuff will be covered today. Next week is Thanksgiving week. If you want me to be here, I will be here. If not, then we can just meet on Zoom if you need to. The week after that will be review week, and I'll be here. I'll just give you practice problems, everybody practice problems, or answer your questions. The week after that is final exams. That's how close we are to the end. We ended up last time talking about chapter 16. Factoring polynomials. We did by greatest common factors first. We just said, what they had in common, we take it out. In section 2, that's where we start looking at factoring trinomials. More so, there's a specific form of trinomial. Trinomials with a equals 1. What does that mean? Remember, a polynomial has this form. That's called the standard form of a quadratic equation. Where A, B, and C are simply the coefficients, the numbers in front of the x's are the constant. Because even though this book doesn't show you all the different ways of solving it, we're in this chapter, we're going to use the rules that they showed you, but then if we don't have time, then when we come back from Thanksgiving, I'll show you a shortcut that will always work. It's just a matter of just plugging it in there. Because you'll see sometimes the hardest part with this is going to be your multiplication tables. So let's review also. Remember last time I had you multiply these binomials together. X plus 3, x plus 2, x plus 3, x minus 2, x minus 3, x plus 2, and then x minus 3, x minus 2. Oh, excuse me. The only thing I've changed in these are the signs between the numbers and letters. That's all I changed. It's plus, 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 minus, minus, plus, minus, minus. And then I had you FOIL these out, multiply these out. And we ended up with, in this first one, we ended up with this factor, this product. In this one, we had that. In this one, there. And that one there. Chapter 15 made us go from here to here. Chapter 15 has multiply two binomials together and we get a trinomial. Chapter 16, we start off with the polynomial and we end up where we began with, where I ask you to look for specific patterns. When you factor these things, these polynomials, this first term comes from where? It comes from this spot times this spot. Let's just go through the FOIL technique. X plus 3, X plus 2. So the first times the first, that's the F, the first terms. That gives you X squared. That's where the first term comes from. The outer terms, two times X is 2X, it's positive. And then the inner terms. So the outer terms, the inner terms, and then the last terms. 3 times 2 is 6. That's why they call it the FOIL method, because each one of these positions are dependent on where they came from. So the final answer is X squared plus 5X plus 6. So this first term comes from the numbers in the first location. So what times what gives you X squared? X times X. The second thing we look at, this is the first thing we look at. The second thing we look at is the second sign. If the second sign is a plus, that means the signs are the same. They are the first sign. So if the second sign's a plus, that means they're both the same. They're whatever the first sign is. So we see in our example here, the second sign is a plus. They're both the same. They're both going to be positives. So first thing, look at the first term. That's that. Then second sign. If it's a positive, then both signs are the same. If it's a negative, the signs are different. One's plus, one's positive, one's plus, one's minus. So if the second sign's a minus, then we have one positive and negative. The bigger number gets the first sign. Once we figure out what numbers we have, the bigger number gets whatever the first sign is. Because all that's been done without any mathematics. It's just observation. The third step, look at the last digit. Is forgot what times what equals the last digit. That when you take the sign in the middle, in this case it's addition, it equals a number in the middle. Right, it'd be 3 and 2 in that case. And there you have it. Yeah, so it's 3 times 2, 3 plus 2. So what times what is 6? When you add them, you get 5, 3 and 2. What times what is 6? When you subtract them, you get 1. What times what equals 6? Yeah, when you subtract them, 3 minus 2 is 1. So in this case, we know the numbers are 3 and 2, but the bigger number gets the plus. So the 3 goes there and the 2 goes there. What makes up x squared? X and x. The second sign's a minus, so they're opposite signs. What times what is 6? When you subtract them, you get 1, 3 and 2, but the 3 goes in the negative. Good morning. We're just reviewing what we did last time. Good. What's the first term? X and x. The second sign is a positive, so that means they're both the same. They're whatever the first sign is, so they're both minus. What times what is 6? When you add them, you get 5. 22. So that's the process. That's the process whenever your leading term, your A, is 1. It changes a little bit when it's not 1. We'll get to that in a little bit. Ready to do some examples? Let's do some examples. Let's factor all of these. You notice these first 4 examples only have 1 variable, and the last 2 we're going to have are 2 variables. Okay, so what goes in the first spot? Yeah, what makes up x squared? X times x. What signs go in there? Yeah, since they're both the same, they're both positives. Okay, I should have not put this one first because it's a trick question. What times what is 8? When you add them, you get 5. 2 times 4 is 8. 2 plus 4 is 6. That's not work. 8 times 1 is 8, but 8 plus 1 is 9. Can you get that? If you can't do it, don't worry about it. That's called a prime factor. They can't go any further. Yeah, it can. It's going to have an option that says cannot be factored, or it's a prime factor, or it's a prime number, or something like that. It'll have something like that says can't be done. You must have experienced one of those questions. Yeah. But which is why I can't wait to show you the other way, the shortcut method, because it will tell you if there's any answers or not, any factors. So how about the second one? What's the first term? X and X. How about the signs? Look at your checklist. Look at the second sign. If the second sign is a minus, what does it tell you? They're different signs. One's plus, one's minus. Where does the bigger number go? The bigger number goes to the negative. So let's figure out what times what equals 4, that when we subtract them, we get 3. Yeah, 4 times 1, 4 minus 1. So the bigger number gets them negative. So it's 4 goes there, 1 goes there. Always, always, always check your answers. How would you check your answer here? Yeah, multiply these out. X times X is X squared. Positive times negative is negative. X times 4 is 4X. Positive, positive. 1 times X is 1X. Positive, negative is negative. 1 times 4 is 4. Combine like terms. 4 is bigger, so it's negative. 4 minus 1 is 3. And they match, so it works. Always check your answers. Because the most common thing is you'll put the numbers in the wrong spaces. It'll be a sign issue. Okay, how about the next one? X. Well, it's a plus. It means they're the same signs. They're both going to be minus. That's why always look at the second sign. The second sign, if it's a plus, it's going to be the same signs. It's going to be that. So they're both going to be minus. What times what is 5? When I add them, I get 2. So what equals 5? 1 times 5 is the only thing, isn't it? Well, 5 times 1 is 5, but 5 plus 1 is not 2. So it's a prime. Because I know the hardest part is figuring out when to let go and not trying to force it to fit. Let's look at the second one. So we know we have X and X. What signs go in there? Yes, second sign is minus, one's positive, one's negative. So we got to figure out what two numbers when we multiply them equal 42. Why do we subtract them? And what does it equal when we subtract them? Yeah, equals 1. And we subtract it because that's the second sign. This is the hardest part right here. 42 times 1. 21 times 2. 4, or let's see. 7 times, no. 6 times 7. Okay, here are the possible multiplications that equal 42. If we subtract any of these numbers, do we get 1? 42 minus 1? Nope. 21 minus 2? Does that equal 1? No. 7 minus 6? Yes, so there we have it. 7 minus 6 equals 1, and 7 times 6 is 42. So these are the numbers. Where does each number go? Where does the 7 go? Since the first sign is a positive, the 7 goes there. The bigger number gets that sign. Make sense? We're gonna do 1,000 more of these, so if it hasn't stuck yet, then it'll catch on. No, in this case it does, because the signs are positive and negative. If the second sign's a minus, they're opposite signs. The bigger number gets the first sign. If that was a minus, the bigger number gets a minus. It's just, so again, there's no thinking about it. It is, since that's a plus, there has to be more of those numbers. So it has to be the bigger number. This just tells you they're opposite numbers. If it's a plus, they're both the same. They both have to be minus in order for that to be minus. So that's, now, what if we had two variables in our equations? Whenever you have two letters, two variables in your equations, what goes in the first spaces? What does x, where does x squared come from? So we know x has to go in the first one. Since this is y squared, it has to go in the second spot. So that's the first spot. This is the last spot. Now we treat it the way we've been doing. What are the signs? Yeah, they're opposite signs. One's positive, one's negative. Now we got to figure out the numbers. What times what is 4? When we subtract them, we get 3. 4 times 1. Where does the 4 go? In the negative. Because the first sign is a negative. And there you have it. So don't be afraid if there's a second sign in there, a second letter. They belong in the first and second spaces. So what goes in the first space here? X and X. And the last space gets a Y and Y. That's where the Y squared comes from. What about the signs? Minus, minus. Because the second sign is a plus, tells me they're the same. If they're the same, it's whatever the first sign is. Put that in your notes somewhere, because I asked the same question and a lot of times people get the same mistake. If the second sign is a plus, they're both the same. They're the first sign. If the second sign is a plus, the signs are the same. They are the first sign. If the second sign is a minus, the signs are opposite. One's positive, one's negative. It doesn't matter how you put it, because of commutativity, it doesn't matter. I just like to put positive first for some reason. The signs are opposite, and the bigger answer gets the first sign. I think when I say first sign, well, here, when I say first sign, I don't mean the first sign, when you put this here, I mean the first sign in the original equation. Whatever that sign is, that's what the number gets. It's not whatever you put in the parentheses. It's whatever's in the original equation. Okay, so we know they're both minuses. What times what is 8? When you add them, you get 6. Yeah, 4 times 2 is 8. 4 plus 2 is 6. And there's your answer. Getting better? Okay. Let's look what happens here. Two x cubed, the middle one's squared. 2x cubed plus 6x squared minus 8x. So what is this? What's the first thing you're going to do here? First thing you always want to do, is there anything they all have in common? Factor out the greatest common factor first. Do they have anything in common? Let's see this. This is 2x, x, x. This is 2 times 3, x times x. 2 times 4, x. Is that going to make it easier? Do they have anything in common now? They have a 2 in common, and they have 1x. So that's the first thing I have to do. I take out what they have in common, a 2 and 1x, a 2 and 1x. So what I have left inside here is that. So I took out what they have in common. Now I have this. Now I have, is this a quadratic equation? Is this a quadratic equation? It's a yes or no answer, 50-50 shot. What is the standard form of a quadratic equation? That's the standard form of a quadratic equation. Quadratics cannot have an exponent bigger than 2. So is this a quadratic? No. So once we factor out something in common, is this a quadratic? Yes, because it's a square here. Once we get to this point, then we can break it down. So what goes in the first spot? X and X. What signs? Yeah, since the second sign is a minus, they're opposite. One's plus, one's minus. What numbers go in there? And where does the 4 go? 4 goes in next to the plus because they're opposite signs. The bigger number gets a plus. 4 times 1 is 4. 4 minus 1 is 3. We're done. Again, I want you to check your answers. Multiply all these out and see what you get. How about the second one? What do they have in common? How many x's? 2. So if I divide each of these by 3x squared, whatever I get goes inside the parentheses. So the 3's cancel. X to the 4th divided by x squared is x2. 27 divided by 3 is 9. I subtract 2 from on top. 60 divided by 3 is 20, and the x's cancel. So I took away 2 x's from each term. Now let's try to figure it out. What goes in the first spot? X and X. What about the signs? They're the same. They're both negatives. Very good. What times what is 20? When you add them, you get 9. Again, that is the hardest part, is your multiplication table. And there you have it. Let's look at this one. What do you think your first step is here? You can't just change signs. It has to be a mathematical reason you do stuff. You can't just change it. It's got a negative in front. So first off, we can take out a negative. If we take out a negative, that's how we change all the signs inside there. Now, inside here, what do they have in common? Okay, let's take out a 3. If we take out a 3, again, since we factor it out, we divide. So 3 divided by 3, the 3's are gone. 15 divided by 3 is 5. 18 divided by 3 is 6. So it's easier again. I told you all from day one. Treat the signs and numbers and letters, treat them all separately, individually. I took out the negatives first. I took out the number next. Now, what do they have? What kind of letters do they have the same? How many of them? Yeah. When you have, everybody has x's or variables, look at the smallest exponent. That's the most they have in common. So I can take out 2 x's. Since I took out 2 x's from each of those, that's what I have. Now we see if we can factor this one. What goes first? What signs? What is it? Right. The same signs to both will be minus. Very good. What numbers go in there? Very good. What times what is 6? When you add them, you get 5. 3 and 2. Very good. There you have it. There's a record. So far, so good. Let's see. Okay, that's the end of section 2. Okay, the textbook itself in this next part wants to show you a more complex way, which I really don't like, so I'm not going to show it to you. I'm going to show you my way. Factoring trinomials, but this time your leading coefficient will not be 1. Let's factor this one out. Yeah, I'll put a sign there. Every sign equals. Here are the steps. First, your first step always, when you're doing these factoring, factor out any common terms. Do they have any numbers in, all 3 of them have numbers in common or letters in common? If they do, factor that out. Second, place AX in both parentheses. Okay, okay. What does this mean? This is your A. Remember, your equation is AX squared plus BX plus C equals 0. A is whatever's in front of the letter. So I put 6X in both of these. Place the correct signs So what signs are going to go inside there? Yeah, since the second sign's a minus, they're opposite signs. One's positive, one's negative. This is where it gets different. This is where it gets different. Because our leading coefficient is not 1, multiply A times C. So this is A, this is C. So I have 6 times 1 equals 6. Whatever the first term is, whatever the constant is, multiply those two together. Find all factors of A times C. So what are all the factors of 6? 6 times 1, 3 times 2. What is there anything else? No. So now you know what numbers you have to deal with. Determine which two numbers plus or minus, whatever the second sign is, equals the B term. Determine which two numbers from this factor equals the middle. So since that's a minus, what two numbers subtract to give you 1? 3 times 2. Place the numbers in their correct locations inside the parentheses. What does that mean? When I say place the numbers in their correct locations inside the parentheses, since they're opposite signs, the first sign is a plus. Why is that important? So I know my numbers are 3 and 2 because the bigger number gets the plus. So the 3 goes there, the 2 goes there. It's the same thing we've been doing. Now, here's the main difference between what we've been doing and now. At this stage, factor both parentheses if possible. Take out what they have in common. So in this first one, what do they have in common? What do 6 and 3 have in common? A 3. So I can factor out a 3. Since I factor out a 3, I got a 2x plus 1. What can I factor out of the second one? Since I factor out a 2, I divide both of those. I got a 3x minus 1. Is everybody okay what I'm doing so far? Now, the last step, erase the numbers you factor out. Erase the numbers you just factored out, the common factors. So what does that mean? I get rid of the 3 and I get rid of the 2. So there's my factor. Those are my factors. So we started off with this. We started off with 6x squared plus x minus 1. And we said our factors are 2x plus 1, 3x minus 1. Always test your answers. If I multiply these two together, 2 times 3 is 6. X times x is x squared. Positive times negative is negative. 2x times 1 is 2x. Positive, positive is positive. 3 times 1 is 3x. Negative 1. 3 minus 2 is 1x. And they did work. So that's my factor. Okay, let's look at some examples here. We have 2x squared plus 7x plus 6. Remember, what's the first step? Can anything be factored out of there? Do they have anything in common? No, because 7's an odd numbers, 2 and 6 are even. So what goes in the first space? Two x, whatever this number is, put them in both of them. Here's an observation. If you look at every example we've done so far, the letter in the first spot is always the middle term. It's always that. What signs are in there? They're both the same. They're both positive. Next step. Take 2 times 6 is 12. So what times what is 12? Do we add or subtract? When we add them, we have to equal what? 7. 4 times 3, perfect. And then 4 plus 3. So it's 4 and 3. We're almost done. What do we do next? Yeah. Can anything factor out of this first parenthesis? So we get x plus 2. Can anything factor out of the second? No. Whatever we factored out, we delete it, and there's our answer. That's our factor. All right, do the next one. Yeah, we have a whole bunch of these. I'm gonna give you a ton of practice on these. Okay, what numbers go in first? 2x and 2x. What signs? They're both the same. They're both positive. 2 times 3 is 6. So what times what equals 6? When you add them, you get 5. 2 and 3. Factor out the 2 in first, you get what? X plus 1. Whenever you factor something, to figure out what goes inside the parenthesis, just divide what you factored out. 2's cancel, the 2's cancel. So x plus 1. Nothing factors out of the second. Erase the first, and there you have it. There's your factor. Let's try this one. Let's try something other than a 2 coefficient. Let's do this one. You're welcome. Yes. Remember, first thing, can anything factor out of the original equation? No, always look at that first before you go any further. All right, so I have my two, nothing factors out, so I have 2 parentheses. Put the 5x in both of them. What signs? The second sign's a minus, so they're opposite signs. If you put both negatives, you got an answer wrong. Now you understand the importance of checking your answers. So because the second sign's a minus, they're opposite signs, the bigger number gets a negative. 5 times 3 is 15. What times what is 15? When I subtract them, I get 2. 5 times 3, 5 minus 3. So the 5 goes in the negative, and the 3 goes in the positive. Anything factored out of the first term? How about the second? 5. If If I take out a 5, what do I have left? Yes, whenever you factor something out, to see what goes inside the parentheses, divide each one of those by what you factored out. Erase the factored form, coefficient, and there's your factor. There's your answer. Again, always check your answer. Multiply these together, you should end up with that. How about with two variables? Let's look at our example with two variables now. Right. So nothing factors out. Again, the first one, I have 15x, 15x, and there's a y. Opposite signs, one's plus, one's minus, and the bigger number will get the negative. 15 times 2 is 30. What times what is 30? When I subtract them, I get 1. 6 times 5, 6 minus 5. Since the first sign is a negative, the 6 gets the negative, and the 5 gets the positive. Yep. What can we factor out of the first one? A 5. So it's a 3x plus y. How about the second one? Fifteen divided by 3 is 5. 6 divided by 3 is 2. So your factors are 3x plus y, 5x minus 2y. Get it right? Both signs also? Good job. Yeah, it feels good when you get it right. Yeah, well, I have a whole bunch more here. So I'm gonna pick some more difficult ones in a minute. Let's do this one. Anything factor out first? A 2. So we have 2x squared minus x minus 15. Remember, we divide each of these by 2 since we factored it out. Okay, here's the important thing. This 2, since we started off at the beginning, this 2 cannot be erased at the end. It has to stay with us. So now what do we put next? 2x, 2x. How about the signs? Positive and negative, very good. Next step. Two times 15 is 30. So what times what is 30? When we subtract them, we get 1. 6 and 5. And since the first sign is negative, the 6 gets the negative. Then we can't factor this first parenthesis because it's a 5. We can take out a 2 of the second. That's the only one we can delete. Only what you factor at the end. So our final answer is that. Again, you have to, it helps if you check your answer at the end to make sure you don't erase too many things. What do you think about this stuff? Difficult? This part here takes other classes almost a week to do it, 2 or 3 class periods because of the moving too many choices. But we did it in 20 minutes. Let's make it look uglier. Let's look at the top left. Just a 3? This one. Well, how much? Just 3? And we're doing this one, not the easy one. We're doing this one. 9, because this is 2 times 9. This is 9 times 7. This is 3 times 9. Yeah, so we take out a 9. And how many x's? So I divide by 9. And I subtract 2 x's from each of those. 18 divided by 9 is 2x squared. 63 divided by 9 is 7. Take away 2 x's. 27 divided by 9 is 3. No more x's. So we got a 2x, 2x. What signs go in there? Yeah, both the same. They're both positives. What numbers go in the spaces? Very good. Everybody see where I got 6 and 1 from? Just 2 times 3 is 6. What times what is 6? When you add them, you get 7, 6 and 1. So now, what can we factor out of the first one? Can we factor anything out of the second? This is the only one we erase. So your final answer is x plus 9x squared, x plus 3, 2x plus 1. Okay, let's do this one. You guys want to do this one earlier? Anything factor out? A 3. So we had, nope, because the first one doesn't have a y. So the only thing we take out is a 3. So the first one's a 2x squared plus xy minus 6y squared. So divide each of these by 3 since I factored it out. What goes in the first spot? 2x and 2x. What signs? Very good. 2 times 6 is 12. So what times what is 12? When you subtract them, you get 1. 4 times 3. So where does a 4 go? 4, since they're opposite signs, the first sign is plus, the 4 gets the bigger sign. So it's 4y. And 3y. Remember, the second letter has to be in the second spot. What can we factor out of the first one? Using x plus 2y. Erase that. And there's your answer. Pick 2 of them from these 4 on this page. I'm gonna do the first one. Okay. Go ahead and work on those, and I'll fill in these for, so when I scan these, you can have all the examples. So go ahead and do these first and last one, and I'll go ahead and work these out. So what do you have for the first one? Two x, what signs? Both positives. 2 times 9 is 18. What times what is 18? When I add them, I get 9. 6 and 3, so the first one I can take out a 2. I can't touch the second one. So there's my factor. And the last one. So your answer should be 2x plus 5, 2x, 3x plus 2. I want to do 2 more on this next page. Let's do this one and this one. These two. All right, so nothing factors out. 6x, 6x. What signs go in there? Yeah, positive and negative, and the bigger number gets negative. 6 times 10 is 60. So what times what is 60? When you subtract them, you get 11. 15 times 4. So the 15 goes in the negative. What does the first one have in common? 3x plus 2. And the second? Get rid of those. There's. And this one. I'll go ahead and finish this last one for y'all. This one. the opposite signs. 4 times 7 is 28. What times what's 28? When you subtract them, you get 3. Yeah, 7 times 4, 7 minus 4. Since it's a minus, so 7 goes there. Factor out of 4 of the first one. And there's your answer. What do y'all think? This one here I tried to work on, and it's what times what is 18? When you subtract them, you get 8. It's a prime. You can't factor, so it's prime. The only thing equal to 18 is 9 times 2, 6 times 3, or 18 times 1. None of those work, so all right. We're almost done, because if you understand that part, the rest of the stuff, other than this part here, we're pretty much done. Once we do this, that's the hardest part, is learning how to factor these things. All right. Section 16.5 deals with what are called special factors. There are 4 types of special factors. Difference of 2 squares. Perfect square trinomials. Difference of 2 cubes. And sum of 2 cubes. All right, the first one. The difference of 2 squares. In chapter 15, when we multiplied polynomials or binomials together, bless you. In chapter 15, we were faced with this example. If you have the same numbers, but different signs inside there, and you multiply it out, what would happen? X times X is X squared. Positive times negative is negative. X times Y is XY. Positive, positive is positive. X times Y is XY. Positive, negative is negative. Y times Y is Y squared. Combine like terms, the middle terms cancel. So we ended up with this. Whenever you have, these are called, remember I told you, these are called conjugates. The only thing different is the sign between them. One's plus, one's minus. Everything else is the same. What happens is whatever this first term is, you square it. Whatever the second term is, you square it and put a minus between there and you're finished. So what would that one be if I multiply it together? No. You have to square it. 25x squared minus what? 9y squared. You have to, when you square it, you have to square the number also. Now we're going to work backwards. If you only have two terms and a minus in between, and there's a square, check to see if it's the difference of two squares. Is this number a perfect square? What's 25 made up of? 5 times 5, so it's 5 squared. What's 9 made up of? So 5 squared x squared is the same thing as 5x squared. 3 squared, that's 3y squared. So we see it's the difference of two squared numbers. If it's the difference of two squared numbers, then it has to be both of these. It has to be 5x 3y, 5x 3y, and different signs. That's the only thing different. All right, let's look at some more examples. Is this one a difference of two squares? Is the first term a square? Okay, first I'll look at, are there only two terms? Check. Is it a minus in the middle? Check. Is the first term squared? Check. Is the second number a perfect square? Now, if that's the case, then we put x9, and just different signs. And we're done. How about this one? Two terms. There's a minus in between there. Are they both squares? 100 is the same thing as what? 10 squared. So the answer is x plus 10, x minus 10. How about the next one? Two terms. Is it a minus between there? Is the first term squared? Is the second term squared? So it's x plus y, x minus y. How about x squared minus 10? Two terms. Is a minus between there? Is the first term squared? Is the second term squared? Nope. That's as far as you can go. and these last two. And you do this one. Is the first term squared? Is the second term squared? Is it a minus between there? Nope, can't go any further. Same thing here. Can't, because it's not a minus sign. Let's look at some more. Now we're gonna do some thinking. Is the first term a square? So it only has two terms, check. Minus between there, check. Is the first term squared? What is it? If it's squared, what is it? 3x squared. What's the second number? So since they're both squared, it's 3x plus 7, 3x minus 7. How about this one? Is the first term 64 a perfect square? It's what? 8 times 8. So this is 8x squared. 25 is 5 squared. So it's 8x plus 5, 8x minus 5. Okay, how about that one? Is the first term square? Yeah, 25 is 5, so it's 5x squared. 64 is 8 times 8, so it's 8y squared. So it's 5x plus 8y, 5x minus 8y. How about the next one? What is that doing there? What's where that came from? How about this one? The 50x squared minus 32. Can we do that one? Are you sure? Okay, but can we factor anything out? Do they have anything in common? Take out a 2. That gives us 25x squared. Half of 32 is 16. How about now? Now it's 5x squared minus 4x, 4 squared. 5x plus 4, 5x minus 4. How about the next one? Is 27 a perfect square? No. 25 is. Is there, no, so, but can we factor anything out of both of those? 3. If we take out a 3, what do we have left here? There you go. Now we have squares. So the first one is going to be in parentheses 3x squared minus 5 squared. Okay, how about the next one? These are curveballs being thrown at you. Is the first one a perfect square? X squared squared. How about the 49? That's 7 squared. So it's x squared plus 7, x squared minus 7. And how about this one? Is this one a perfect square? It's what? Very good. Excellent. 9x squared plus 4, 9x squared minus 4. Very good. Actually, I'm very happy how fast you guys are picking this up. Well, but once you walk out that door, it'll be gone. It stays only in this room. It's like a Harry Potter room. Okay, so that is the first one. That's the difference of 2 squares. So now we're going to look at perfect squares. What is a perfect square? We have 2 types. So a perfect square represents this. If we multiply these 2 together, we get x squared plus xy plus xy plus y squared So there's the formula for perfect squares. Okay, now I gave it to you, I showed it to you, but what does it mean? What if I gave you this? Using this formula, this is what it means. this first part, it says whatever this first number is here, square it. So it's 3x squared. Plus 2 times the first term times the second term. So 2 times 3x plus 2x plus the second term squared. This is just a shortcut. So we have 9x squared. 2 times 2 is 4 times 3 is 12. Is it everybody okay how that works? Just pretty much what x and y. X represents whatever's in front of the plus. Y is whatever's after the plus. We have to go backwards. What if I gave you this? Asked you to factor it. 3 things you have to look at. You have to look at 3 things. First, is the first term a perfect square? It's made up of 3x squared, right? Is the last term a perfect square? It's made up of 2 square. Now comes the test. If I take this first term times the second term and double it times 2, does it equal the middle term? 3 times 2 times 2 is 12x. If it satisfies those 3 conditions, then I know it's a perfect square. Then I know it's a perfect square. Okay, let's look at some examples. Is the first term a perfect square? Yes. Is the last term a perfect square? What is 16 made up of? 4 squared. Now, if whatever's under the square, if I multiply those 2 together and times 2, does it equal the middle? X times 4 times 2 equals 8x. Because that satisfies that, I know my answer, my factor is that. It's the first and last term added together squared. It's added because the second sign's a plus and the first sign's a plus. That means all the signs have to be pluses. The second one, does that satisfy the condition? Is the first term a square? Yes. Is the last term a perfect square? Does 1 squared equal 1? Yes. If I multiply 1 times x times 2, do I get the middle term? So because that is true, then it's x plus 1 squared. Let's look at these. Is the first term a perfect square? Yes. Well, that's supposed to be a plus. Well, we can do it minus also. Right. Is the second term a perfect square? Yes. If I take 9 times x times 2, do I get the middle term? 9 times 2 is 18 times x is s. So I know it's x plus 9 squared. Let's look at the same one now. If that middle sign, if the first sign was a minus. If the first sign's a minus, then the sign between the two terms is a minus. Because remember, they have to be the same. They both have to be minus, so it's that. So when you factor these things, if it's a perfect square, whatever the first sign is, goes inside the parentheses. But again, it has the same satisfy. The last term times the first term, 9 times 2 times x has to equal the middle term. How about this one? Is this a perfect square? It's 4x. Guys, yeah. Is the last term a perfect square? 7 squared. 7 times 4 is times 2, 56. So we know our answer is going to be 4x plus 7 squared. It's plus because the first term is plus. How about this one? Is 121 a perfect square? It's what? 11 squared. So it's 11x squared. Is 100 a perfect square? 10. 10 times 11 is what? 10 times 11 is 100, 110. Times 2 is 220. So you're trying to force it in there. So we know the answer is going to be 11x plus 10 squared. How about this next one? Is 64 a perfect square? So it's 8x squared. Sign's a minus. And 9 is made up of 3 squared. 8 times 3 is times 2. So it works. So it's 8x minus 3. It's a perfect square. Let's throw a curveball in there. 27x cubed plus 72x squared plus 48x. Is 27 a perfect square? Or can we factor anything out? What can we factor out? We can factor out a 3. And they each have an x. So if we take out a 3x. 27 divided by 3 is 9. Lose an x. 72 divided by 3 is 24x. 48 divided by 3 is 16. And the x's are gone. So this one is 3x squared. This one is 4 squared. 3 times 4 is 12, times 2 is 24. So the first sign's a plus. There's our factor. Because it's a perfect square. Okay, so that's the difference of 2 squares and perfect squares. Let's go to the next larger ones, cubes. Difference of 2 cubes. Again, we only have 2 terms. And they're both cubes with a minus between there. If this is true, if you have 2 terms that are cubed with a minus between them, then it's a difference of 2 cubes. The factored form will be this. Whatever's under the cubes goes inside the first parenthesis. Inside the second one, it's going to be x, xy, y. The first and last terms are squared. The second sign is always plus. The first sign is opposite. This sign here is opposite where this one is. Here's an example. X cubed minus 8. Is this one cubed? Yes. Is an 8 a cubed number? It's 2 cubed. 2 times 2 times 2. According to this formula, in the first parenthesis, you put whatever's under the cubes. Take the x, the first term, and square it. Plus x times y, so it's 2x. Plus the second term squared. So it's x minus 2, x squared, plus 2x, plus 4. And there's a factored form. Let's look at some examples. We have two terms. It's a minus between there. Is the first term a cube or a square? It's a cube. It's a 3. 64. Is that a squared term or a cubed term? Can it be cubed? Because we don't have a rule that says one's cubed, one's squared. It's 4 times 4 times 4. So this is 4 cubed. Since it's the difference of 2 cubes, I take whatever's under the cubes, put it in the first spot. Now inside the second one, square the first term plus these two together multiplied plus the second term squared. X minus 4, x squared, 4x plus 16. And there's your factored form. How about the next one? Is it a perfect difference of 2 cubes? Is the first term perfect cube? That's 2x cubed. No. But neither is this. Can we do anything to help it? Factor out of 2. If we factor out of 2, we get x cubed minus 27. And 27 is made up of 3 times 3 times 3. So what goes in the first parenthesis? And the second one is x squared plus 3x plus 9, 3 squared. And there's your answer. How about the next one? Is the first term a perfect cube? Yeah. 8 is made up of what? 2 times 2 times 2. So it's 2x cubed, because this is 2 cubed, minus y cubed. In the first parenthesis, 2x minus y. Remember the second one, since in these, the cubic ones, you have to have one minus and two plus signs. You have one minus and two plus signs in your final factor. There's a minus, so the other one's pluses. And the second one's always plus. The first term is this term squared. The first term. So 2x squared is 4x squared. Two times y times x is 2xy times y squared, or plus y squared. And there you have it. And the last one here. Four is not a cube, 32 is not a cube. So what can I do? Factor out the 4. So I have x cubed. 32 divided by 4 is 8, y cubed. So we have 8y cubed, the same thing as 2y cubed. 8 is made of 2 times 2 times 2, y cubed. So my factored form would be x minus 2y x squared 2xy plus 4y squared. Yeah, so you just take the term and square it. So it'll be 4y squared. So far, so good. That's the difference of two cubes. How about the sum of two cubes? That's the next one. The sum of two cubes. It's going to look almost identical to the difference of two cubes. The only thing difference is where the signs fall. Remember, whatever's under the cubes goes inside the parentheses. In the first parenthesis. Remember what I just said? In your factored form, you have to have one minus and two pluses. The second sign's always plus. That means this one. These signs are always opposite. And everything else is the same. So the only thing changes in the sum and difference of two cubes is where the sign, the first two signs are. Everything else is identical. Is this the sum of two cubes? Yeah, because one is the same thing as one cubed. Whatever's under the cubes goes in the first spot. What signs go in the second one? Minus and a plus. Square the first term, which is x squared. X times 1 is x. 1 squared is 1. And there you have it. And we're almost done. So this is the same thing as x cubed plus 2 cubed. Whatever's under the cubes goes in the first parenthesis. X squared, now it's a minus 2 times x plus 2 squared. X squared minus 2x plus 4. So the only thing changes is where the first two signs are. And they have to be opposites of each other. Is 64 a perfect square? Our cube. Yeah, it's 4 cubed, x cubed plus 1 cubed. So it's 4x cubed plus 1 cubed. So yeah, the first parenthesis, whatever's under the cubes goes in there. The first term squared minus the first term times the second term plus the second term squared. Now let's have some big ugly numbers. What's 27 made up of? So it's 3 cubed, x cubed. How about 343? We know it's bigger than 5 because 5 times 5 times 5 is 125. 6 times 6 is 36, times 6 is 216. So it has to be 7. 7 times 7 is 49. 49 times 7 is 343. So we have 3x cubed, 7y cubed, whatever's under the cubes goes in the first parenthesis, 3x plus 7y the first term squared minus the first term times the second term plus the second term squared. Nine x squared, 21xy plus 49. Are we okay with this so far? And the last one, 8 is made up of what? Yeah, so it's 2 cubed. 125 is 5 cubed. So we have 2x plus 5y. This first term squared, which gives us 4x squared. This times this, 5 times 2 is 10xy, so it's minus 10xy. The second term squared, 25y squared. Now, again, each one individually is pretty easy, but now if I just give you some off the chart, then you start thinking about this, which here's a rundown of what you have to look for. When you factor polynomials, first, factor out any common factors you can. If all of them have x's, factor out the x's. If they have any number, make the numbers as small as possible before you do anything. If you have a binomial, if you only have 2 terms, check to see if it's a difference of 2 squares, if it's a difference of 2 cubes, or sum of 2 cubes. Check to see if any of those exist. If it's a trinomial, see if it's a perfect square, like we did today. If not, then factor it the way we did earlier. And always check your answer. These are, take it piece by piece by piece, step by step by step. I mean, I had a whole bunch of other examples here also we're going to work on, just, but I'll work them out and give them to you all. I want to show you where we're going to with all this stuff. Why factor polynomials? The answer? To find their solutions. Solutions are the x-intercepts of the graph. This is what it's all coming down to. This is what it's all about. We're learning how to solve polynomials, so we learn how to solve to find the x-intercepts. To solve, first step, set equal to 0. Whenever you have a polynomial, everything has to go to one side. Set it equal to 0. Factor out any common terms. And factor the remaining polynomial. We will use a method called the zero product principle. The zero product principle. What it says is this: if I have two numbers and I multiply them together and they equal zero, what has to be true? Well, yeah, it means either A is zero, or B is zero, or A and B are zero. Because anytime you multiply a number times zero, it's zero. And since we don't know which one's which, we set them both equal to zero. Example. Solve for the x-intercepts. We set it equal to zero. There's nothing we can factor out of here. So let's factor out. What goes in the first spot? X and X. What signs go in there? They're both positive. What times what is 6 when you add them, you get 5? Yeah, 3 times 2, 2 times 3. Once we get to this point, we take both of these equations and set them equal to 0. Subtract 2, so x equals -2. Subtract 3, so x equals -3. These are my x-intercepts. Those are my solutions to my polynomial. That's what we're looking for. So let's solve these last 6, and that will do it for the semester. Remember, you have to put your equation in standard form. This is what's called the standard form. Set equal to 0. So what signs go in the first one? Plus and minus. What times what is 5 when you subtract them, you get 4? 1 times 5, and where does the 5 go? In the negative. So my answers are x equals -1 and x equals 5. Those are my solutions. The second one, we can't do too much with. Why not? This is a cubic function to begin with. It's not a difference of two cubes or sum, and they don't have an x as each of them. So this, we can't do anything with this one. What probably happened is I miswrote the question down. Oops. Okay, how about this one? So what's the first thing you gotta do? Is it in standard form? What is standard form? Here it is. Is this standard form? That's standard form. It's set equal to 0. Is it set equal to 0? So we have first thing we have to do is make it so we add 3 to both sides. So 2x squared plus 7x plus 3 equals 0. Now we factor it. So we have 2x and 2x. What signs go in there? They're both positives. Your answer should be -3 and -1/2. Because what times what is 6? When you add them, you get 7, 6 and 1. 6 and 1. The first parenthesis, they have a 2 in common, so I take out a 2, so I have x plus 3, 2x plus 1. Set them both equal to 0, solve for x. You get these answers. Is the next one. How would you solve that one? Look at it. Is it quadratic? Or is it linear? Look at see these? If you have an exponent, that's a polynomial. In this case, it's a quadratic equation. There's no exponent. So this is a linear equation. How do you solve linear equations? That's chapter 2, 1 and 2, remember? If it's linear, we have to solve for y. So we subtract an x from both sides. 2y equals -x minus 4 divided by 2. negative 1/2x minus 4/2, which gives us negative 1/x minus 2. So what's the y-intercept? Minus 2. What's the x-intercept? Nope, that's the slope. The x-intercept. To find the x-intercept, we set y equal to 0, so the x-intercept is negative 4. That's all chapter 1, chapter 2 stuff we forgot about 11 weeks ago. This is why I want you to do a lot of your work over the Thanksgiving break, so it refreshes all your notes again. Two more questions. Solve that one. What's the first thing I gotta do? Has to say equal to 0, so I have to subtract 4 from both sides. Has to be equal to 0 before I do anything, because it's a polynomial. Opposite signs, very good. What times what is 4 when you subtract them, you get 3? 4 times, and 4 gets a negative, very good. So your answers are negative 1 and 4. Just in time, because it's our last question. What do you have to do the last one? Here's the equal sign. I have to minus 9x and then add 8. Let's move everything over to the left side. Has to be equal to 0. What signs are in there? They're both the same. They're both negative. What times what is 8? When you add them, you get 9. So your answers are 8 and 1. That's the course. And algebra really, the next part of this really, after the semester, I really suggest you guys take the test again and see how well you do.